Okay, we're now going to look at suitable domains and restrictions on the domain. Now, the domain is basically numbers that you input into the function. So if we're going to input 5 into a function to get an answer out the other end, we would say that that was part of our domain. So we're looking to establish numbers that can be excluded and included in the domain. So that's what's suitable to be in the domain and what is not suitable. Now, in maths, what we can't have is division by 0, because that will give me an undefined result, and the square root of a negative, which will always give me an undefined result as well. So two things that we're thinking about here in terms of restriction on the domain is division by 0 and square root of a negative number. So let's have a look at how that will come into play in some of these questions. Okay, so let's start with a question as follows. The functions f and g are defined in suitable domains by f of x equals 1 over x squared minus 4, and g of x is x plus 1. Okay, the first question says find h of x, which is given by f of g of x. Okay, so that's part A. Okay, so h of x is given by f of g of x, so that's f of x plus 1. Okay, so the f function is given by whatever's in the bracket is on the denominator of the fraction. It's squared. You then take away 4 with a 1 on the numerator. So whatever is in the bracket is written down on the denominator and is squared. You then take away 4 on the denominator, and then there's a 1 on the numerator. Okay, so that's 1 over x squared plus 2x plus 1 minus 4, which can simplify to 1 over x squared plus 2x minus 3. Okay, so that is the h function now. H of x is equal to 1 over x squared plus 2x minus 3. Okay, part B says write a restriction on the domain for h. Okay, so two things that we're thinking about here is we can't take the square root of a negative number and we can't divide by 0. Okay, there's no square roots involved, so let's look at option 2. Now, the denominator then, what we're saying is the denominator cannot be 0. So the denominator cannot be equal to 0. So if we then factorise that, two numbers that multiply give minus 3, add together give 2 is x plus 3, x minus 1 cannot be 0. So x plus 3 cannot be 0, x minus 1 cannot be 0, which means x cannot be minus 3 and x cannot be 1. Those are the restrictions on the domain. Now, by implication, all other real numbers except 1 and minus 3 are absolutely fine, so they would be suitable for the domain. So the restrictions are minus 3 and 1. Okay, let's try another, which is going to be find k of x, which is equal to g of f of x, where g of x equals 1 over x and f of x is equal to x squared minus 2. Okay, so k of x, which is g of f of x, g of x squared minus 2. So the g function is whatever's in the bracket is on the denominator of a fraction with 1 up top. So whatever's in the bracket is on the denominator of a fraction with a 1 up top. So part B, write a restriction on the domain. Well, the denominator cannot be 0. So x squared cannot be 2, x cannot be the square root of 2, which will be a positive negative result. So the restrictions on the domain this time are positive root 2 and negative root 2. Okay, let's try another. G of x equals the square root of x plus 7. And the question then says, write a suitable domain for G. Okay, so remember that we can't have the square root of a negative. Now that means the thing in here cannot be negative, which means it must be greater than or equal to 0. Therefore that occurs when x is greater than or equal to minus 7. So the suitable domain is that x must be greater than or equal to minus 7. Okay, let's try another. This time f of x is equal to 1 over x squared minus 4. G of x is equal to 2x plus 1. Okay, so part A says find an expression for h of x where h of x is equal to g of f of x. Okay, so that's g of 1 over x squared minus 4. Okay, so the g function is whatever's in the bracket, you write it down, you double it and you add on 1. Whatever's in the bracket, you write it down, you double it, and then you add on 1. Okay, so let's just simplify this. So that would be 2 over x squared minus 4 plus 1. Okay, and I can simplify that. So 2 over x squared minus 4, I can get a common denominator here of x squared minus 4. Remember that anything written by itself is equal to 1, so I can change that 1 into x squared minus 4 over x squared minus 4. I've now got a common denominator. So that will be x squared minus 2 over x squared minus 4. Now remember that this is the function given by h of x. So I'm actually looking for the restriction on h. The denominator cannot be 0. Okay, difference 2 squares. X plus 2 bracket x minus 2 cannot be 0. X plus 2 cannot be 0 and x minus 2 cannot be 0. So x cannot be minus 2 and x cannot be 2. Final answer.